Now we are discussing about the construction and function of galvanic cell or voltaic cell. What is this galvanic cell? It is a device which is used to convert chemical energy. That is, energy released in a chemical reaction is converted into electrical energy. The device which is used to convert the chemical energy into electrical energy is called galvanic cell. So the galvanic cell, it consists of two electrodes, a zinc plate or zinc rod placed in zinc sulfate solution. Zinc plate or zinc rod in zinc sulfate solution acts as anode. This is the zinc. And a copper plate or copper rod in copper sulfate solution acts as cathode. And these two plates are connected by copper wire through copper voltmeter. And these two beakers are connected by a salt bridge. Salt bridge is an inverted U-shaped glass tube in which a jelly-like substance agar-agar is present, and it is saturated with an aqueous solution of saturated KNO3 and KCl solutions. So here zinc, it acts as anode. Each zinc atom, it releases 2 electrons on this plate and enters into solution as Zn plus 2. And these 2 electrons are passed through this copper wire. Here Cu plus 2 ions are present on this copper plate. Each Cu plus 2, it takes 2 electrons and becomes copper, which is deposited on the copper plate. So zinc acts as anode, oxidation takes place. The reaction takes place at anode is oxidation, and copper electrode acts as cathode. Reduction takes place. This is the overall reaction. Anode half cell reaction, cathode half cell reaction, and the complete cell reaction is Zn plus Cu plus 2 gives rise to Zn plus 2 plus Cu. This is complete cell reaction. Here, what is the role of salt bridge? Salt bridge consists of agar-agar gel saturated with KCl and KNO3. Here Cu plus 2 ions are deposited on copper and SO4 minus 2 ions are present here. In this, each zinc atom from zinc rod enters into solution as Zn plus 2 and leaving 2 electrons. ఇందులో ఉన్న జింక్ ఆటమ్స్ అన్ని Zn plus 2గా మారుతుంది, ఎలక్ట్రాన్స్ అటువైపు వెళ్తుంది. Cu plus 2 డిపాజిట్ అయింది, SO4 minus 2 మిగిలిపోయింది. సో ఇఫ్ దెర్ ఈస్ నో సాల్ట్ బ్రిడ్జ్, పాజిటివ్ చార్జ్ is accumulated in one half cell and negative charge is accumulated in the half cell, which prevents the flow of current. So the cell will not work more. So here the salt bridge allows the flow of ions from one half cell to another half cell. But the solutions, they do not intermix with each other. So sulfate ions from this cell, it moves towards Zn. ఇందులో SO4 minus 2 ions ఇలా ట్రావెల్ అయ్యి ఇక్కడ ఆల్రెడీ Zn plus 2 is there. So electrical neutrality is maintained and circuit is completed. Flow of electrons in this direction and current flow in this direction. So by this way, if salt bridge is there, electrical neutrality is maintained and cell works continuously and it produces electric current. How the electric current produced by this galvanic cell is calculated? For this, there is a formula EMF, reduction potential of cathode minus reduction potential of anode. Under standard conditions, I mean at 298 Kelvin and 1 atmosphere pressure, the reduction potentials of different electrodes are calculated with the help of standard hydrogen electrode. The standard reduction potential of copper electrode is represented like this: Cu plus 2 Cu, and its value is 0.34 volts. E naught Zn plus 2 Zn, it represents the standard minus 0.76 volts. That is the standard reduction potential of zinc electrode. Plus 2 0 plus 2 0, decrease in oxidation state, reduction. The value given here is the reduction potential of that particular electrode. Standard reduction potential. Now EMF is equal to reduction potential of cathode. Cathode means copper electrode. 0.34 minus of minus 0.76. 0.34 plus 0.76. 1.10 volts. So for a cell which works spontaneously, ఏదైనా ఒక సెల్ కంటిన్యూస్గా పనిచేయాలి, its EMF should be positive. Then only the cell works spontaneously. And this cell, it is also represented by IUPAC notation. In this notation, first anode is represented and then cathode is represented, and the two electrodes are separated by a salt bridge. We have taken Zn, which is converted into Zn plus 2. It is a anode. Two parallel lines represent salt bridge. Rendu గీతలు గీయాలి. And cathode reaction Cu plus 2 Cu. It is also represented like this: Zn oblique Zn SO4, salt bridge, Cu SO4 Cu. This is IUPAC notation. This galvanic cell produces a voltage of 1.10. When zinc sulfate and copper sulfate solutions are taken 1 molar. ఎంతవరకు ఇది పనిచేస్తుంది? కంటిన్యూస్గా పనిచేయాలంటే జింక్ రాడ్ మొత్తం కరిగిపోయేంత వరకు పనిచేస్తుంది. కాపర్ సల్ఫేట్లో ఉన్న కాపర్ మొత్తం డిపాజిట్ అయ్యేంత వరకు పనిచేస్తుంది. అయితే ఈ అరేంజ్మెంట్ అనేటువంటిది కొంచెం డిఫికల్ట్ కాబట్టి, అంటే జింక్ రాడ్ తీసుకోవటం, గ్లాస్ వెసల్ పెడతాం, సాల్ట్ బ్రిడ్జ్ పెడతాం, ఇవన్నీ కష్టం కాబట్టి దీన్ని మాడిఫై చేసాం. దట్ ఈస్ డానియల్ సెల్. డానియల్ సెల్ అనేటువంటిది చాలా చిన్న ఎక్విప్మెంట్ ఉంటుంది. ఒక సెల్లోనే, డానియల్ సెల్లో ఒక సెల్లోనే యానోడు క్యాథోడు తీసుకుంటాం. ఈ మధ్యలో ఒక పోరస్ స్పాట్ ఉంటుంది. ఈ పోరస్ స్పాట్లోంచి సల్ఫేట్ అయాన్స్ SO4-2 అయాన్స్ ట్రావెల్ అవుతుంది. అండ్ దిస్ పోరస్ స్పాట్ యాక్ట్స్ లైక్ సాల్ట్ బ్రిడ్జ్. No more salt bridges. Both anode and cathode are placed in one box. ఒక దాంట్లోనే ఉంటాయి. మనకి ఎక్విప్మెంట్ చాలా సింపుల్గా ఉంటుంది, ఈజీ టు క్యారీ. ఇలాంటిదైతే కష్టం అవుతుంది. సో ఇక్కడ మనం గమనించాల్సింది ఏంటి అంటే, ఇన్ జనరల్గా యానోడ్ పాజిటివ్, cathode నెగిటివ్. కానీ ఇన్ galvanic cell, the electrons are always present on this plate or rod So it carries negative charge. Here cathode, Cu plus 2 ions are always placed on this plate. It carries positive charge. In normal electrolytic cell, which is used in electrolysis process, anode is positive and cathode is negative. In electrolytic cell, electrical energy supplied to the electrolysis process, మనం ఇచ్చినటువంటి ఎనర్జీ ఎలక్ట్రాలసిస్కి కెమికల్ రియాక్షన్ జరగడానికి ఉపయోగపడుతుంది. యానోడ్ దగ్గర ఒక సబ్స్టెన్స్, క్యాథోడ్ దగ్గర ఒక సబ్స్టెన్స్ రిలీజ్ అవుతుంది. కానీ ఇక్కడ ఎలక్ట్రికల్ ఎనర్జీ క్రియేట్ అవుతుంది. ఒక కెమికల్ రియాక్షన్ వల్ల ఆ ఎలక్ట్రికల్ ఎనర్జీ క్రియేట్ అవుతుంది. అక్కడ దానికి దీనికి డిఫరెన్స్ అది. Electrolytic cell in which electrical energy is converted into chemical energy. Electric energy leads to the chemical reaction. But here a chemical reaction, the energy released in a chemical reaction is converted into electrical energy. So this what is reduction potential? The tendency of an electrode to gain electrons is its reduction potential. The tendency of an electrode to lose electrons is oxidation potential. For an electrode, the reduction potential and oxidation potential numerical value is same. That is, the magnitude is same, but the sign is different. You can write the reduction oxidation potential for copper electrode as Cu gives rise to Cu plus 2 minus 0.34. Similarly, Zn gives rise to Zn plus 2 plus 0.76. So that is oxidation potential. Generally, we solve the problems by considering reduction potential is ఏదో ఒకటి ఫాలో అవ్వాలి. రెండు అయితే కాస్త కన్ఫ్యూజ్ అవుతారు. కాబట్టి రిడక్షన్ పొటెన్షియల్సే ఫాలో అవుదాం. ఈఎంఎఫ్ క్యాలిక్యులేషన్స్కి కేవలం రిడక్షన్ పొటెన్షియల్స్ మాత్రమే ఉపయోగిద్దాం. రిడక్షన్ పొటెన్షియల్ ఆఫ్ క్యాథోడ్ మైనస్ రిడక్షన్ పొటెన్షియల్ ఆఫ్ యానోడ్. వాట్ ఈస్ సింగిల్ ఎలక్ట్రోడ్ పొటెన్షియల్? వాట్ ఈస్ రిడక్షన్ ఎలక్ట్రోడ్ పొటెన్షియల్? వాట్ ఈస్ ఆక్సిడేషన్ ఎలక్ట్రోడ్ పొటెన్షియల్? Reduction potential, oxidation potential. The tendency of an electrode to gain electrons is called its reduction potential. What is the value of reduction potential of a metal electrode? అసలు ఎలక్ట్రోడ్ అంటే ఏంటి? జస్ట్ ఇట్ ఈస్ ఎ మెటల్ రాడ్ ఇన్ మెటల్ సాల్ట్ సొల్యూషన్. A metal rod in metal salt solution. That is nothing but electrode. What is its electrode potential? How to calculate? A single electrode, it cannot produce electric current or voltage. So when it is connected with some other electrode, the cell may produce voltage, current. But that is only the difference between the reduction potentials of two electrodes. What is the absolute value of an electrode potential? ఏదైనా ఒక ఎలక్ట్రోడ్కి ఎలక్ట్రోడ్ పొటెన్షియల్ ఎంత ఉంది చెప్పలేము. In order to measure the electrode potential of an electrode, a standard electrode is constructed which is called standard hydrogen electrode. That is called SHE. SH. Its electrode potential is arbitrarily fixed as 0. It is a standard. What is this hydrogen electrode? It is a platinum plate coated with a platinum block connected to a platinum wire. It is covered by a glass tube in which a hydrogen gas is present at 1 atmosphere. And it is kept in 1 molar HCl solution, H2 gas at 1 atmosphere pressure. Here platinum wire or platinum plate acts as supporting electrode. This is a very simple normal hydrogen electrode or standard hydrogen electrode whose electrode potential is fixed as 0. How it acts as an anode or cathode? Anode means oxidation. When hydrogen electrode acts as anode, the H2 gas here, in this H2 gas present here, it is converted into 2H plus and releases 2 electrons. When hydrogen electrode acts as anode, the 2 electrons on this plate travel through this platinum wire and goes away. When hydrogen electrode acts as cathode, hydrogen electrode as cathode, 2 H plus ions which are present in 1 molar HCl solution takes 2 electrons and becomes H2. When hydrogen electrode acts as anode, the H plus ion concentration in HCl solution increases and H2 gas pressure decreases. When H plus ion concentration increases, pH decreases. Because the pH is equal to minus log H plus concentration or log 1 by H plus ion concentration. When hydrogen electrode acts as anode, the H plus ion concentration increases, pH decreases. When hydrogen electrode acts as a cathode, the H plus ions in solution enters into glass tube as H2 gas. The pressure increases. H plus ion concentration decreases, pH also decreases. So this is a hydrogen electrode whose electrode potential is fixed as 0. With the help of this hydrogen electrode, the electrode potentials of other electrodes are calculated. This hydrogen electrode is known as primary standard electrode. But it is very difficult to maintain H2 gas pressure because it is a lighter gas, it easily escapes away. So with the help of this primary electrode, primary standard, a secondary standard electrode is constructed. With the help of that secondary standard electrode, the electrode potentials of remaining electrodes are calculated. The secondary standard electrode is calomel electrode. What is this calomel electrode? How it is useful to calculate the electrode potentials of other electrodes, we will discuss later.